Hello, good afternoon to you all, and you are welcome to our data modeling session. We'll be looking at database modeling and design with SQL. So my name is Carlos, and I'm one of the consultants at LIT, and I'll be taking you through this session. Today we'll be looking at the relational data model, mainly focusing on the logical design. So for the past weeks, we've been looking at the conceptual design. Today, we are going to start with the logical design. And in the logical design, it's very much related to what we saw in the conceptual design. We'll be looking at the tables, the columns, the relationships come here again. But then we'll be looking at some major characteristics of the logical design, where we talk about the keys and constraints, and then the normalization. So we start with the relational model, the relational data model. The relational model represents the database as a collection of relations. So in this case, the relation is just plainly a table of values. So just like the table that you see here, it's similar to what you are used to in Microsoft Excel. So it represents the data as a table of values. Each row in this table represents a collection of related data items. So every row is about a particular stuff. When you take each row, it contains information or data about a particular stuff in relation to this data that we see here. So that is the relation. In the entity relationship model, we saw relation as entity. So the entity in the entity relationship model becomes a relation in the relational data model. Then the attributes there becomes columns here. Here they can also be referred to as attributes or columns. It doesn't really matter. Then the rows of data or the records are called tuples in the relational data model. So it could be referred to as tuples or rows or records of data. So each record would contain data values about a particular staff. And each of the staffs would have information about the staff ID, the first name, the last name, the email, and the phone number, as per this diagram that we see here. So each of the values that you see in there, they are fields, or they could be referred to as data values. This is how the relational model is represented. In the entity relationship model, we saw it in visualized mode. So everything was visualized in some form of a diagram. In the relational model, it's mainly about table of values arranged in rows and columns, and each of them containing the intersection of the row and column containing some data value or a field. So we'll be looking at some characteristics of these relational data model and some things you can do, some things that are not permitted with the relational data model. First, we talk about the relation name. We say you need to maintain a distinct relation name. Each relation in a database must have a distinct or unique name, which would separate it from other relations in a database. So let's say we have one relation, employee, which has attributes ID, name, date of birth, sex, department. Then we decide to create another relation, also having ID, name, but this time it has age, phone, and job role. But because they are both talking about employee, we decide to call the second one also employee. In relational data model, this is not accepted. You can't give two relations or two entities the same name. Whether they have the same data values or not, you need to give it a distinct relation name. So that is one of the characteristics of the relational data model. So let's take another one. We talk about the distinct attribute name. A relation must not have two attributes with the same name. Each attribute must have a distinct name. Each attribute must have its own distinct name, just like we saw with the relations. So this is also an employee data set with ID, with name, with date of birth, with department. Then the designer or whoever decides to create another attribute called department, but this time it's containing different data values. Even though it contains different data values, you can't have two attributes having the same name. Relational data model doesn't accept this. So all the attribute names or all the column names must be distinct from each other. Then we talk about the tuples or the rows of data. We say duplicate tuples must not be present in a relation. We take this. There we have about 4 different sets of employees or 4 records of employees. But we realize that the first employee and the last in the table have the same set of records. The ID is 1, the name is Samuel, they have the same date of birth, the sex is the same, the department that they work for is the same. This would not be acceptable in the relational data model because it says that you can't allow duplicate tuples. Now, one thing about this design too is this: when you structure your database well, the existence of the key attributes or the primary key in this relation would not even allow it. In this relation, we see that ID is the primary key. How do we know it's the primary key? Just by seeing that it's underlined. So if you have any relation and you see that one of the attributes or a set of attributes are underlined, that represents the key attribute or the primary key. Some systems use a small key icon to represent the primary key. So anytime you see a small key icon beside one of the attributes, that is a representation for the primary key. Now, when your relation has a primary key, it would surely prevent duplicate tuples. But when you are designing the system will not force you to create the primary key. It assumes that you know what you're about and allows you to create it. So you as the designer, you need to enforce that constraint to make one of the attributes the key attribute. Then it would prevent these kind of entries. Because obviously, if you have a relation of employees where 2 employees have the same ID, having the same name with the same date of death, then there should be some problem. All the other attributes could be the same, but the ID alone should be distinct from 2 different employees. So relational data model doesn't allow allows distinct tuples. It doesn't allow duplicates. Okay. So in this case, we would have to remove that second occurrence of that employee in our database. Then we talk about the order of tuples. Tuples in a relation do not follow a significant order, as the relation is not order sensitive. So let's take these 2 data sets, both of them employee data sets. It contains the same set of values, but you'd realize that the order of the records are different. The first one has 1, 2, 3. The second has 3, 1, and 2. Now we are saying that in the relation, these 2 are very equal. There is no problem with it. You don't necessarily have to create your relation so that number 1 will come first, number 2 will come second. No. Number 1 could be the third attribute, the third record in your database, and it would work very fine. It's all about the database being able to access the information. Wherever the data set is, the database would be, or the DBMS would be able to retrieve the data and display it for the user. So the order does not matter in relational databases. The same way with the order of the attributes. The attributes of a relation do not have to follow a certain order. It's up to the developer to decide the ordering of the attributes. When we look at these 2 data sets also, the same employee contains the same set of values, but you realize that the arrangement of the columns or the attributes are different. So a lot of the designers would want to place the key attribute as the first one. That's just by convention, but it's not a rule that you must follow. By convention, it's better to put it there so that it's easily identifiable. But all the other ones can be mixed up. Whether it is coming at the last end or it's the second attribute, it doesn't really matter. What matters is wherever you place the column header or the attribute name, all the data values that correspond to that column header should fall in line with it. So in this particular case, you can't have name somewhere at the third column, then you have the data value showing the department information over here. It doesn't work like that. So relational data model says that the order of the attributes does not really matter. It's up to the developer or the database designer to decide how to order his or her attributes. Okay. So this is the same thing. Then we also talk about the single data value. We say each tuple must have exactly one data value for an attribute. Each tuple must have exactly one data value for an attribute. When we're looking at the entity relationship model, where we talked about a simple attribute and the composite attribute. We said that the composite attribute could be further split into simple attributes. The same way we have for the multi-valued and the single-valued. It is the same concept that is being demonstrated here. When we take a look at this, we have 3 rows of data of employees. But when we take a look at the third row, you see that there are 2 names there. The relational data model says that this here is not acceptable. It doesn't allow more than one data value to be placed in your row of data. It always has to contain one, so you'd have to split it. If there are 2 different people, you have to split it. If it's the same person with 2 names, then you have to create a different attribute for it. If there are 2 different people, then you need to create 2 different rows or tuples for that data set. That is mainly done to enhance the search when you're searching for data to generate your reports or to perform some analysis on the data. It's easier when each attribute has its own set of data than putting 2 or more data sets into one field. Then we talk about the data value from a particular domain. So each value in a tuple must be from the domain of the attribute for that column, or it must be from a particular type of data. So when you're defining the attribute, you need to specify what kind of data it's supposed to store. So whatever value you place there should correspond with the data type that you specified for it. In this employee data set, we realize that the sex column for employee number 3 has a different type of data. All the other records have alphabets or characters for their data, but the third record has numeric values. That shows some difference in the set of data. So that is not acceptable. Every attribute should have a set of domain, or the values for the attributes should correspond with that set of domain.
Hello, Carlos.
So yeah.
That's true. It's not acceptable because I'm a male.
Okay. Well, yeah, so you're a male, so we need to change your sex value to male, then the data becomes a good one, or it corresponds with the relational data model. Now let's look at the last of the characteristics. We talk about a special null value. We said this is used to represent values that are either unknown or not available or inapplicable to certain tuples. And in a data set, sometimes you'd find null values in your data set just like this. people have different interpretations to null values in a data set. When you take a look at this data set, employee number 1 has null value for phone. Now, if someone wants to interpret this data, someone can say, maybe the employee doesn't have a phone, so he doesn't have a number. Someone would also say, maybe he has a phone, but we don't know the number, so we leave it blank. We can't put anything there. Or maybe those employees there are not supposed to, or maybe that particular employee is not supposed to use a phone, so that place should be null. This is acceptable in relational data models. Nulls are acceptable, but when they are used, they are overused, it becomes problematic. One of the issues with the problem is it creates wastage in storage. Now, any data value that you store in the database is assigned memory location on the computer. So when we take ID, based on the data type that is reserved for ID, so if we say ID is an integer, the computer reserves a place to hold or to store an integer. It's the same for each of the columns or each of the attributes. So for employee number 1, there'll be a space reserved for phone, expecting to hold a data value. But because it's null, nothing will be put there. The same for all others. Maybe for this one, it wouldn't take up much space. But if you have thousands of data records and there are a lot of null values, you'd see the impact of wasting your storage space. Another disadvantage of using nulls in your data set is when the data cannot be explained very well, or during analysis, you can't really give a conclusive report on employee number 1's empty value for phone. In this case, you might end up making assumptions. Maybe the person doesn't have a phone, or maybe we don't know the phone number, and that doesn't make your report credible. So in designing databases, we try to reduce nulls as much as possible. How do you reduce that? If you take an attribute where almost for all the records, the whole column is going to be null, then it's better you take it out. So let's assume that for this employee data set, we have a new column called maybe fax. When you put fax here and you realize that most of the employees do not have a fax number, so they're not going to provide any value for fax number, then it's better to remove the fax number because it might not necessarily apply to the entity that you are designing the data set for. This is very much talked about when you are normalizing your data. As part of the first normal form, this is one of the things that ought to be implemented for your data to be of good quality. I have this cartoon over here. This is the database administrator or the data architect. Then this could be maybe the business analyst or one of the team members. So he comes to ask the data architect, we were just wondering what table 5.column3 holds. And then this data architect says, I don't remember. What are we trying to say here? Now this table 5.column3, you'd find that a lot of designers would name their columns like this. Without proper documentation, then it becomes problematic for all the other people who will be trying to access data from that database. So some data architects don't bother finding meaningful names for tables and columns. This poses a great challenge for querying, for reporting, and analytics. So it's always advisable when you're giving names to your relations, to your attributes, make sure you give names that give a representation of the kind of data that you are storing in there. So that even without proper documentation, anybody who sees the data set should be able to explain the meaning of that data set. Yeah. So that would be all for this afternoon's introduction on the relational data model. Next week, we'll be looking at one of the very important aspects of relational data model, where we talk about the the integrity constraints. With the integrity constraints, they are more like the rules that govern how data need to be stored. So we'll be talking about three main rules. We'll be talking about the key constraints, the entity integrity constraints, and the very much important referential integrity constraints, where you are combining data from two or more tables to represent or to provide reports on that. So we'll be looking at that next week. Okay, so we'll now take questions and answers, any discussions, any feedback on our session. Would take that quickly. So if you have any question, you can just unmute your mic, or you could just type in the chat window, then we'll look at it.
Hi, my name is Deborah. Can you hear me?
Yeah, I can hear you, Deborah.
You were talking about attributes. When you were talking about, is there a best practice model for ordering attributes? You said it depends on the designer how they order the attributes. Yeah. I was thinking, is there a best practice way of ordering it, or is it just as the designer chooses?
So with the attributes, most of the time it's just as the designer chooses. But by convention, people would like to have the key attributes at the beginning. So that's mostly the IDs. So if it's for an employee, you'd have the employee ID. If it's for maybe students, you have the student ID at the first one as the first attribute to be displayed, so that it can be easily identified. For all the other attributes, there's no really any lay down rules on how to order your attributes. Some people also like to have all the other unique attributes closer to the key attributes. So let's say in a set of departments, you'd have department ID as the key attribute, then the name of the department would follow it in that order. But most of these are just logical. You just create your own order for it, but there's no lay down rule for the ordering of the attributes.
Okay, thank you.
Welcome. Any other question?
Carlos, it's Barbara. Thank you. Thank you very much for this session. So as a BA who's documenting the specifications for a data integration project, one of the columns, I guess, what kind of information will I need to ask the developer in terms of the table? You know, like the specification table, you'll probably ask what source, data source, what attributes are you extracting. Obviously, the SME will give you those data sets. Yeah. You mentioned constraints in this session, and I'm wondering who would give you those constraints, those the order in which, say, for example, a data attribute should go. I don't know if I'm making sense. I'm trying to familiarize.
Yeah.
Is it the SME or is it the developer?
I think it's
will I have to obtain? Sorry.
No, you finish, sorry.
So I'm thinking of the constraints. The constraints are the rules, right? In terms of what order do you want the first name or the surname to go to? What other information will be relevant in my requirement gathering for this particular modeling exercise?
So when you are modeling your data, it's mainly a collaborative work. So it's good to work. Most agile teams would like to collaborate to work on this. So there would be the SME, there would be the, the developer or the data architect, there would be the business analyst or the product owner. Now, the SME alone cannot provide you all the data. They'll provide you, but because it's the developer or the architect who is supposed to store the information in the database, he has that technical idea of how the data is going to be stored. But he needs some clarification, or he would need some clarification from the SME and the business analyst as well. Now, so the business analyst would now have to get information from these two people. Sometimes it depends on the scope of data that you are working with. You might have to find out the data type. Very important.
Yeah.
Then sometimes you need to look at the length of data. So for example, when I'm creating an attribute for a name, when I specify that the name should be a set of characters or a set of varying characters, where I say it's varchar, I would set a limit. Now, on my own, I might say that, okay, maybe the first name of someone should be up to 15 characters. But the SME would know that the kind of people that I deal with, maybe some would have maybe 30 characters in their name. So he would have to communicate that information to the analyst and the developer that, okay, because of the people that we work with, some of the names can be very long. And so you need to give a wider limit or a larger limit for the names. Sometimes you need to look at some of the business rules. Now, the business rules now apply to how the business is being operated. The developer no way can determine those business rules. An example of a business rule would be maybe if it's an employee record system where you want the system to trigger the retirement age. So some people would have maybe 60. Maybe some other systems would have 50. So it is the operations guy or the business guy that's supposed to communicate that to the developer to be able to implement or enforce that rule in the system. So mainly the information will be coming from the SME, but it's a collaborative work.
Thank you very much.
Welcome, Laura. Any other questions?
Yes, Carlos.
I will.
Thanks very much, Carlos. Fantastic session today. Yeah. Now, I know the question I'm going to ask you is two, but you've addressed one of it partly. In the fields, okay, when you have to input the data, yeah, I was thinking of how, if you, like now where everybody's working virtually, so you have people from different sort of countries, and then you have all these very lengthy names, some names like names from the Indian subcontinent, very long, yeah, and then telephone numbers, okay? If you have a field for a telephone number, it has to have different codes, yeah? Which means plus this. So how can we ensure that in the field, the data that we input is acceptable, and when we want to pull it out, it would not generate an error? I'm not too sure what I've been able to communicate what I'm trying to say.
Yeah, I get you.
Okay.
I understand.
You just have been racist.
that must be Zafar.
Yes, that's Zafar.
I don't have a long name. I thought Nigerians have the long name, but not 1, 2, 3, 4, 5 names. I'm only joking. I'm only joking.
Don't worry, I don't take offense in anything.
Okay, so let's talk about the name first. So with the name session, so let's say you create the data type for name, and you specify that it's varchar, and you set the limit to, let's say, 20. And someone's name is 25 characters. What will happen is the database will truncate it. It will cut off the name at 20 characters and then discard the other 5 characters, which will mean that the value that you are putting in your database is going to be erroneous, or is going to be a mistake, inaccurate data. To prevent all of these, the varchar can take up to 255 characters. I don't know whose name, just for one name, would be up to 255 characters. If that is it, then we might have to split that name column. But yeah, usually you would have the name less than 255. Now for the phone, for example, there are 2 ways that you could do this. The phone number can be taken as a composite attribute. Composite where you would have to split it. So you can create a different field for the country code, and then the phone number section would take a different field. That could solve that problem. Another way is, instead of, no, even in both cases, actually, the data type for the phone would have to be generic. You can't use a numeric data type to store the phone number, especially when the plus is coming in. And then even when there is no plus and you are ignoring the country code and you are storing only the phone number, some of the phone numbers would have to start with 0. If you use an integer to define the data type, the integer sees 0 as insignificant, so it ignores it and it's going to cut it out and start the number from the second digit. So we normally use varchar for phone numbers. That is if you are if it's an international phone number where you don't even know the number of characters, the number of digits for the phone number for other countries. If it's the same country, normally you would have a specific number of digits for the phone number. Then you can use CAR for that. So CAR would limit it to exactly that number of digits or number of characters for the phone number column. But if it's varchar can take less, but not more than. So these are different ways of addressing that phone number. And okay, so Zafar put a name there.
Yeah, I'll share the one Sri Lankan name, but I used to study with Sri Lankan people, and they have such a long surnames.
Okay. So in this case, you'd have to split the names into, you can't put all three into one field. It's not good to do it that way. So you should have maybe the first name, the middle name, and the surname or the last name.
Split like a story in Agile, yeah?
Yes, exactly. So each of them would have maybe up to 50 characters.
Wow.
This should be able to hold each of the names here. So you have to, based on the context in which, or the scope that you're working, that would define what kind of data type you would implement in your database. Okay.
Thanks very much, Carlos.
Yeah.
But just to sort of clarify here,
Okay, yeah.
if, like you always used to have this popular phrase, you used to use garbage in, garbage out, yeah? So if some of these sort of limits or delimitations are not set from the outset, it means that it could compromise the integrity of the data, basically.
Very much, yeah, very much. So let's say if you don't set maybe your key attribute at the beginning, or you allow for name column, you allow numbers to be entered into the when people are filling forms or maybe online forms, they would put any garbage in data into it. And that would mean your database is going to be a data of garbage data. When you're generating reports that would help you in your analytics, then you find that the reports that you are generating are not going to help you to make any good business decisions. So it's very important to get it right from the beginning. Sometimes you can make some changes whilst the data is in there. Some minor changes can be made, but if they are major, then it could affect all the data. You might have to extract all the data, transform the data, then reload it into the database.
Yeah, I was looking at it from the angle of, the banking system where the data is very, very important now. And if there's any mistake, you could sort of, probably maybe pick some money from people, or people pick some money from other people's account and things like that. The data, yeah. All right. Thanks very much, Carlos. It's very useful. Thank you very much.
Thank you, man, for the interaction. Isaac, your hand is up. Do you have any comments or questions to?
Oh, mine is just straightforward and simple. I just want to know where I can get your playlist from. That's all.
I'll give it to you. I'll send them to you. Okay. Thank you very much for this session. If there are no more questions, then we'll end this session. So I'll see you. We'll meet next week. But on Monday and Tuesday, we'll be meeting for the agile testing and automation. And on Tuesday, we'll continue with the business agility, focusing mainly on the SAFe framework. So make it a date and join us on Monday. Have a nice weekend.
Hello, please. I'm also interested in a playlist.
Okay, I'll make that available during the next session.
Thanks, Carlos. I'm also interested in that playlist too.
Yes,
It's
make
dope,
them plus
man.
one too.
Dope. The playlist is dope, man.
Thank you very much.
Thank you.
I'm just sitting here. I got time.